Welcome to Khetz Tutorials, and in this video, I'll be covering question 26 from 1.1 exercises in James Stewart Calculus. So here's our question. A spherical balloon with a radius r inches has a volume Vr equals that. Find a function that represents the amount of air required to inflate the balloon from a radius r inches to a radius of r plus 1 inches. So if we were to visualize this, I'm just going to use a simple two-dimensional diagram just to show this. And let's imagine that the yellow part is our current sphere, or this is our balloon right now, and it has a radius of r. We now want to have a bigger sphere, a bigger balloon with a radius of r plus 1. So r plus 1. So that green line represents our new radius r plus 1. And the question is asking for a function that represents the amount of air. So that air is essentially this red part here, this red portion which I am shading. And if you look at it, we now have a bigger balloon and the original one inside. So if we subtract this balloon which is inside from the green one, we will just have the red portion, which is the difference, and that difference over there is the air which we need to inflate the other one. So if we were to delete this, so by subtracting, we're actually going to delete this portion. The only thing that remains is just the air in between. So that's the approach which we're going to use. So our new volume is 4/3 pi r plus 1 to the power 3, and we're subtracting the smaller balloon which was inside to get the air, or that space which is in between the two. And now if you expand this, if you expand r plus 1 cubed, you're going to get r cubed plus 3r squared plus 3r plus 1. And that is going to subtract what we have here. We haven't changed anything on this side. Then we can factor out the 4/3 pi because it's common. That would leave us with r cubed, and we're going to take this r cubed there just so we have the like terms next to each other. So that would be minus r cubed. Then we can copy everything else. So this is where we are right now, and r cubed minus r cubed is 0, and we just have 4/3 pi and this portion, so 3r squared plus 3r plus 1. If we multiply through, we're going to have the following. So just going to have 4 pi, because there's 3 and that will cancel, so 4 pi r squared. Then once again this 3 and that 3 will cancel. Then we have 4 pi r, and finally this side, that's just the 1 multiplying this, so you're going to have 4pi/3. And that is your answer for the function which represents the air which we need to expand from the small balloon to the bigger one, or the space in between the two balloons.